Hi, welcome to the next video. This week I'll be talking about open source identity access or in specifically OIDC. You might not know what it is, but you use it every day. Ever wondered that while moving away from username passwords to like single sign-ons, like you can log in with Google, Facebook, or maybe Twitter, ever wondered how it works? Gone are the days where you're actually typing in your passwords and logging in. So now it's all in a single sign-on ecosystem where you don't have to worry about it much. You can just open maybe Facebook and just sign with Google. But in the backs of that, there is a lot of things happening. And we need to also understand why such a system was even needed. The first reason for that is being systems were becoming very complex and in there's a term called realms where you you get access to a system and you can access multiple resources. So delegating your access was becoming a bit of an issue in the modern era compared to the olden era where you had basic static pages and blocks. Nowadays we have much more complex applications. So in that scenario, the OIDC was created. There was something called open authorization which was created before that. The main idea was to make it really secure for the users, that is you and me, for using applications. Second reason is the security aspect that OIDC actually provides to the users. It's much more complicated and difficult to attack the OIDC systems, and there are active developments happening over there. So for this scenario, I'm actually taking an example of an open source OIDC implementation called Keycloak. They use it for authentication and authorization purposes. In very layman terms, it lets you log in and it lets you access what all resources are assigned to you. So that's basically it. But first of all, I'll show you a small thing in my terminal. I'll just increase it a bit. So in open OIDC systems or open ID connect systems, how your authentication and authorization or how you log in and how your access management is controlled is basically by two tokens. One is your ID token, which is, hey, I'm Varun and I'm logging in. This is actually telling the web application or the service which is using the OIDC that hey, if I receive this token, hey, I can let this guy in. And there is another thing called the access token, which tells the system what level of access I have. So this kind of changes the password logging completely because you have two tokens here. And if you are not using the system for a while and you try to log in, then you can send in the refresh token to get another new access token in. So you don't need to regenerate, you don't need to every time hit the OIDC server and create new ID token and access tokens and refresh tokens. So this is a really good implementation that they have. So let's look more into it. So I actually have some of the source code here of OIDC Keycloak, and I won't be going through much because this is a really large code base. I want to cover some of the key areas here and tell you how it is different from the normal login where you're using username and password. So in the Keycloak package, they have an OIDC in the service folder in it. Let me just go up, and I don't think you'll be able to see this because it's huge. So if you go to their GitHub page, you can go to their services. In services, you go to protocol and you go to OIDC. Inside there, you mainly have these files. That is the OIDC login protocol, which is the one that is actually handling the authentication part. The authentication part is actually done. uh, it's very complicated, but I'll try to like really simplify it. When you are trying to send a request, I have some of the default request here. I guess I can increase the size of this as well. So this is a setup that I have. uh, I'll just make it really easy. So I have the open the Keycloak service running at localhost 8081. So how I did it is that I created a new client inside of there, and I named it the new client. That is the name here. And the redirect URI will be your website. Say if you are using facebook.com or whichever it is, that will come here. So it's going to redirect the tokens that is going to get, and it is tokens, it's going to create an authentication code which I'm going to show you here. So the scope will be, oh yeah, okay. uh, you will have a redirect URI, which is basically the site that you're trying to log into. Might be facebook.com or maybe Twitter. You're using Google, so in this example maybe you have a scope will be your personal information, like email, username, um, such PIIs or personal identifiers. And response type is the really cool thing. I want it as a code. What I'm telling the system to do is that, if this thing is correct, send me a really specific code so that I can use that to log in. The code will be like an opaque code. What I mean by an opaque code is that it's like a random string that you can see right here. The code here looks like a random string. It's not a token or anything here. And state, here I'm giving random string. So this is actually to prevent CSRF attacks. That is, the browser is actually, or the client, your app is actually generating a code and it will be putting it here. That will be X, Y, Z, anything that can be here. And a random nouns as well, like if you are having any hash such a 256, anything like that, that is here. So if I send this along, then I get a callback that looks like this with the state, um, and the code. This is the most important thing. um, the code, we use it to send a post request to the server, the OpenID Connect, to get the actual access and ID tokens. You can see a client secret that is here. This is actually there in the OpenID system. If I go into the administration and if I go into clients, this is the client that I created, and the credentials, I have a client secret here. So it's actually sending in this client secret for the authentication purpose. You can change this to even more secure implementation where you're using your own generated uh, opaque key, and you're sending it out, and you hash it, and the system checks it at its server side to find that, hey, this is a legitimate thing. So that is even more secure than this. um, so once it's all accepted, see, I'm sending in that request to the client secret and the code. You get the access token, the refresh token, and ID token. This really, really simplifies how the authentication. It's not simplifies, it makes it way more secure. Uh, that is the main reason why people use OpenID Connect. I think a lot of systems nowadays are using it. So now you know what some of these parameters now mean. The response type will be the code, the redirect URI will be the website that you log into, the nouns, the request URI. There are a ton of stuff here. Uh, uh, yeah, this is a key verification also that is present for this. Is something called proof of key code verification. That is what I told about the hash. So they have that it as well there. And main authentication is handled by the authenticated method here. So this is the actual one where the flow is the authentication session, the user session, will be the parameters here, and it is actually sending OIDC protocol response type parameters, and it's redirecting the UI here. So this is the code that is mainly the function that is mainly handling the initial authentication. uh, then there are a ton of functions here. These are all following different RFCs that are set. So there's a lot of RFCs when I was going through the code. This is also pretty cool stuff which I didn't know prior. That is the financial APIs. So financial APIs require to be really secure. So they have some implementation for that as well. Then something I saw in the code that was really cool is, yeah, so if I go to social, they have different implementations for different services if you want to integrate with Facebook, GitHub, GitLab, Google. So these are also pretty cool to check out how they provide the identity provider for it and things like that. So main thing about uh, OIDC is that how it transforms your um, username password authentication to a more secure thing. And see, in the application you are never entering in your passwords. Your application is sending a request to the uh, key server, or the authorized authentication server, or the authorization server, or auth slash authorization server, and just seeing the code, and it is using the code to get the actual tokens back. So your passwords or anything are not being compromised in any of these systems. So it's a great implementation that we have here, uh, that helps us to use modern day systems. And this is also a federated system. What I mean by a federated system is that the system actually allows like large level of access controls, like one authentication leading to multiple access controls. So that is also great here. um, yeah, this is kind of the request that actually happens for it, which I was showing in the text here. Yeah, that's about OIDC. I hope you liked it. It's a short video, but it's a really really important thing that we deal with every day. Thank you so much for watching. Take care.